Hey guys, Brian here. Today I wanted to show you a technique on how to package your resources with your Go application that will still allow you to have a single executable binary and still allow your code to be go-gettable and be fetched and built in one shot. With this technique, which is using go-bindata and go-generate, you can package resources, whether they're images for your game, 3D model data from Blender, or GLSL shader code. You can embed these all into your program so that you can confidently open them and you don't need to worry about whether your installer unzipped the files in the right location or not. You can quickly access your resources in your code. And during development, you can type one command to update them quickly and test your code out. First, we're going to install go-bindata, go-binary data, a small utility which will convert our resources into byte arrays and generate some source code for us that we can then use to load up our resources. If you go to the website for go-binary data, which I'll put in the description, it tells you how to install it. And one thing I always keep doing was I would forget to put the 3 trailing dots, and I would install something, but I wouldn't get the go-bindata executable. Next, like the examples show, you can simply run go-bindata over some folder that has your resources. In my case, in my main Go apps directory, I've got an internal package, an internal directory to hide some of these implementation details, another package called Ponzi, and finally a directory called data where I put all the resources like the code that I showed you and the images before. So once you do that and run go-bindata, you'll see a bindata.go file show up in the same directory. And if you take a look at that file, you'll see that it's a generated file and it tells you exactly what resources it included. Here I've got a meshes blend, object, fragment and vertex shader, and a PNG. And you can see that it's embedded all the data as a binary slice. And it also generates some additional helper functions as well. But here you can see that some of these files I may not want to include, like the blend file, which is only something that can be opened in Blender. So let's get into more of those details soon. But first, let's take a look at what go-generate does and see how that can improve our resource packaging flow. Go-generate can be used to integrate another tool like Yak and produce source code needed to be integrated into the build process so that their output can be compiled. In our case, we're using go-bindata to generate source code rather than Yak, and we want to integrate it into the Go build system, which is all about the singular Go tool. An example in this blog article, they give an example of running Yak, and all you need to do is put this command in your source code, but with a comment prefix and go:_generate. Now you can simply type go-generate and it'll execute this command, which will generate some file, and then you can check that source code file into your repository. Now I'll show you the final setup that I've done for my application, the stock chart viewer Ponzi 2, and I'll show you how I combine go-bindata and go-generate together. For Ponzi 2, my stock chart viewer, I've got a package main where all the action starts. It parses the flags and it simply calls the run method in the Ponzi package. On line 9, I already have a go-generate command that actually just calls go-generate on a sub-package of the same code base. And the reason I put this go-generate here was so that I could type go-generate at the root of the directory and trigger all the other go-generate commands in the sub-packages. And still I wanted to hide all the implementation details about the resources, so that's why I just link this to another go-generate. If we look at the internal Ponzi directory, you'll find in ponzi.go the real go-generate, which calls go-bindata. And here I've got a very helpful comment that explains what it does. I'm going to give myself a pat on the back, but it also includes a bunch of other flags that weren't in the example on the go-bindata page. The first is you can change the package of the generated file. Here I've made it Ponzi because I'm generating it in the Ponzi package, and I want all the source code files to be able to reference it. Next, I stripped off the prefix data, and the prefix data came from the fact that I have a directory called data where I'm going to generate all the resources from. So instead of saying data/texture.png, I can reference the file just with texture.png. Next up, you can ignore certain file types. I've ignored a blend file here using a regex, and the blend file is a Blender 3D file that I don't want packaged into the binary, but I want it checked in right next to the other resources that I used, so that in case I lost all my source code, I could still open this, check it out, and go back to what I was doing. Finally, we have the data directory, which is the folder with all the resources. And if we look at the bin-data go file, we can see that it's got the right package and includes all the resources except the blend file. And finally, to use these resources, we can simply call must_asset, which returns a byte slice and the name of the resource. As I mentioned before, I can just do texture.png instead of data/texture.png due to the dash prefix flag that strips off the data part. Another useful flag that could be useful is to do -debug. What this does is instead of creating the slices with the binary data, the hex data, what it will do is replace those with stubs that do typical file.open calls. And that code will hard code the paths to the files, like d:\work/go/source, and that won't be cross-platform, but it could be useful while development, since you won't have to type go-generate every time you change your resources. But in this situation, to make your application go-gettable, I've simply generated the bin data file, and I check it in, and I turn off debug mode. That way the Go application can be completely built using the go-get command and will work regardless of the platform. Even though Windows and Linux have different slashes and different paths, bin-data.go will still work because the resources are directly embedded as byte slices into the code. So that's the setup I've been using for both Ponzi, the stock chart viewer, and also an unfinished game called Bloxlin that I've been working on for way too long. But hopefully this helps you out. Make sure to like, comment, subscribe, and again, thanks for watching. See you later, guys. Bye.